to Darren Networks. In today's lab, we're going to be going over Etherchannel. So let's get right into it. So what is Etherchannel? Etherchannel is basically a technology that allows you to bundle multiple Ethernet cables or links into one logical link. So for example, in this lab, we're combining two physical interfaces, FA02 and FA03, to logically, on both sides, to logically operate as one logical interface, like it's called a port channel. And so that's what Etherchannel is. And then why do we use Etherchannel? The reason why we use it is one, since you're aggregating or combining links together, it in theory is supposed to um, increase bandwidth, because say if both of these links are both 100 megabytes per second, combined it should be 200 megabytes per second. Same thing on this side, you know. And then the second benefit is redundancy. So just because one link for some reason goes down or goes bad, you still have the other link up, and you could do two. You got 2 links, 4 links, 8 links. I think on some switches you can actually go up to a total of a bundle of 16. Um, you know, so that's the benefit, is redundancy and aggregating the bandwidth. So you're basically increasing your bandwidth. Now, to touch more on the redundancy, something I found interesting recently, I was watching a Network Chuck video, and he was touring basically like the World Cup, their network infrastructure. And one part of the video that stood out to me, just to touch on it briefly, about Etherchannel. I don't know if they were. I don't think it was actually Etherchannel, but it just touches on the importance of redundancy. He asked one of the engineers, like, why do they have multiple links basically carrying the same exact video traffic? I think, like, why can't you just use one link? Because there's no redundancy there. His simple answer was failure is not an option. So, we cannot possibly allow um, something as serious as the FIFA World Cup, or almost any network. No one wants it to go down. So that's the importance of having redundancy. If one link goes down or two go down, you still have another two, you still have another four, however many links you have bundled together with either channel. So that's the importance of redundancy. And then to touch on the increased bandwidth, from what I've read, it doesn't always actually work like that, because if there's just one, say if PC1 was trying to talk to a server, more than likely the traffic is just going to go over one link. It doesn't, in the real world, it doesn't always perfectly evenly distributed the traffic between multiple physical links. So that's something to keep in mind, is that the increased bandwidth doesn't always work as you might imagine it would. But I just wanted to mention that briefly from what I've read and from what I understand. Um, so that's what is Etherchannel. Why do we use Etherchannel? Like I said, it bundles physical links together to create one logical link. We use it to increase bandwidth, combine interfaces together, and in theory, it's supposed to combine their speeds to, make the bundle faster, the link faster, and provide more bandwidth. And then redundancy. If one link goes down, you should still have another one for redundancy. So that way the network ideally never goes down. Now there are two different protocols that you can use when configuring Etherchannel. You have the IEEE Open Standard LACP Link Aggregation Control Protocol, and then you have the Cisco proprietary Port Aggregation Protocol. The most commonly used is Link Aggregation Control Protocol, the Open Standard, because it's open standard, so you can use it on Juniper switches, Arista, and Cisco. So it's probably the most widely used protocol. And port aggregation, it will only work on Cisco switches since it's Cisco proprietary. So the difference is pretty much just in the modes that you configure. LACP uses active and passive modes. Um, so at least one side of the bundle needs to be active. The other side can be passive, but ideally it just makes the most sense to just make both sides active. For PAgP, it uses desirable and auto mode. So same thing, you want one side to be desirable, and it makes the most sense for both sides to just be desirable, but the other side can be auto, and it will still form the port channel. If you have both sides or configured as auto or PAgP, neither side is gonna, they're both passive. They're both not gonna make a move unless, the other side is desirable and is more proactive and gonna dynamically create a link. For LACP, if both sides are configured to passive, they're both passively waiting. So neither side is gonna make a move or do anything to configure it. So at least one side has to be active and going to go make it happen. And then for PAgP, at least one side has to be desirable to go and make it happen. Right. So that's the difference. Open standard, IEEE, Cisco proprietary, desirable and auto, and active and passive. All right, now let's get into the configurations. So I already configured that we don't need a default gateway because there's no router. But PC1 192.168.101/24, PC2, no, same thing, no default gateway. .1.2/24. And I already configured on the switches just to save some time that FA03 here is going to be an access port since it's going to a PC. This is going to be an access port going to a PC. All right, just so we could focus on more of the trunk link and creating the channel group, just to focus more on that. But we will be using the PCs for pinging purposes though. But all right, we'll start with switch 1. Enable CompT. First command that we want to use is channel group 1 mode. We're going to configure both sides to be active for this first one. Active. Oh, whoops, let me get an interface range. So first thing you got to do is get an interface range 3. Okay, channel group 1 mode active. There we go. So you can see here the virtual interface was created. So we're going to do interface P01. We're going to make it a trunk. And then we're going to allow VLAN 10 because that's the VLAN I have my access ports in for the PC. They're both in VLAN 10. So that's it. That's it for that side. Now for switch 2, pretty much the same thing. I'm going to make both sides active. LACP. Same thing. Interface range. Interface 01 to 2. Channel group 1 mode active. And then we're going to go ahead and do interface P01 port mode trunk. Port trunk allow VLAN 10. And now we're going to go ahead and verify the Etherchannel. Actually, I'm going to skip ahead a little bit just so these links could come up. Do show Etherchannel summary. Alright, as you can see here, the protocol is LACP. And then for ports FA01, FA02, we can see that the P here means that they're in a port channel, right? And then the U here means that the capital U, it means that they're in use. Okay, so on switch 2, everything looks good. LACP and port channel and use, everything looks good. Let's check switch 1 side to show Etherchannel summary. Same thing, P and port channel, U and use, LACP, everything looks good. Now we'll try some pings, make sure the trunk link is working good. As you can see, the replies come right through. Alright, so pings go through, the Etherchannel summary looks good. And that's because both sides are both LACP, right? Same protocol for both the IEEE open standard, and they're both using active. You know, if they were both using passive, things would have went wrong. Or if we mixed the two, things would have went wrong. LACP and PAgP. But for this lab, actually what we're going to do to test is, what I'm going to do is, I'm going to change, right now I'm going to change switch 1 from LACP to active mode to PAgP desirable mode. And I'm going to leave switch 2 as LACP active mode. And we're going to see what happens. We're going to verify the Etherchannel summary, and we're going to try some pings again to see what happens. Let's get right into it. So we're going to do interface range FA02 to 3. Node channel group 1. So that deletes it. And then we're going to do node interface P01. Now we're going to get back into it. To 3. Channel group 1 mode. This time we're going to do desirable instead of active because we're doing PAgP. Channel group 1 mode desirable. We have to recreate the trunk link. Interface P01. Port mode trunk. Allow VLAN 10. VLAN 10. Okay. And like I said, we're not going to touch switch 2 right now. We're going to leave it as switch 1 having PAgP, which is Cisco proprietary, and switch 2 is having LACP, which is the open standard. So let's see the results. You show Etherchannel summary. Whoops. Now, interestingly, we will see instead of P, like we previously seen, it now is an I. And what does the I mean? The I means standalone. So FA02 and FA03, instead of being in a port channel like they were when both sides were LACP, now they're both standalone, right? And then over here, instead of a capital U for end use, now is down. Now the port channel is down, capital D, right? And we can see the protocol has changed to PAgP, whereas before it was LACP, and you know it was U and P, right? And now we go over here, check switch 2, channel sum, same thing, I for standalone, FA01, FA02, and then D for down. And you know, we didn't change the protocol, it's still LACP, but because of that mismatch, they cannot create the adjacency and they cannot form the port channel, right? Um, and then now we'll check the pings again. As you can see, the ping is not going through. 1.2 is stuck. You know, you can see the flashing going on there. Same thing, stuck. Pings aren't going through, whereas before the pings went right through. That's because of the trunk not being able to form. But now what we're gonna do, so how do we fix this? The way that we fix this is we could either go to switch 1 and switch it back to LACP, active mode, or it could be passive like I said earlier, but it just makes the most sense to do it active. Or what we're actually going to do is switch to, we're going to change it from LACP and we're going to have it set up to use PAgP just like we did on switch 1. And that should resolve the issue, but let's test it and find out. So we'll do interface range, same thing as we did on switch 1 to 2, node channel group 1, and then node interface P01. Then we'll go back into interface range, and we're gonna do channel group 1 mode desirable, just like on switch 1 for PAgP. And then the logical interface, we're going to create the trunk again, interface P01, mode trunk, switchboard trunk, allow VLAN 10. And now skip ahead. Alright, now let's check to see the summary. And as you can see, that resolved the issue. So instead of I for standalone, as you can see, the ports are now saying P for import channel as they were the first time. And then we have a capital U for end use instead of D for down. Right? So everything looks good on switch 2. Let's double check switch 1. Same thing. P, everything looks good. U is up. I mean, it's in use. It's in the port channel, all the ports. Both sides are using PAgP, as you can see here. And now for the final test, let's see if the pings go through now. As you can see, the pings are coming through right away this time. Right away. Alright, so we went over everything. All of these questions. How does Etherchannel respond to the link failure when both sides are not configured in a compatible way? Obviously, you use LACP on one side and PAgP on one side, then they're not compatible. The bundle, the port channel is not going to form. So yeah, this was a good lab to configure Etherchannel. That's pretty much it for today's lab. Maybe in the next lab, next project, I'll go over spanning tree protocol. But we'll see. We'll see what I decide to do for my next project. But I hope you all enjoyed. If you can, leave a comment of any questions, any thoughts, concerns, you know, anything I might have did incorrectly, anything, any advice. If you're actually in the field or just anyone, if you've seen this, like how would you actually implement this in a real enterprise network? Do you have any stories, any advice, anything to look forward to? I mean, like in the future, like look out for, I meant to say, when configuring Etherchannel, anything you experienced, anything like that. Just any thoughts, comments. I appreciate it all. I'll read all the comments, take any advice, take any constructive criticism or feedback. So But that's all. So thank you all for watching, Darren Networks. Um, and I'll see you all in the next video. Thank you.